Hi everyone, welcome to this episode of Keipert Labs. In today's video we're going to talk about the greenhouse effect. So we're going to start by looking at reminding ourselves about the atmosphere. We're going to look at the electromagnetic spectrum, the concept of solar radiation. We're going to look at what is a greenhouse. We're going to discuss that in the context of this thing called the greenhouse effect, and we're going to look at these things called greenhouse gases. So what is the atmosphere? Well, we've looked at this idea before, this idea that the atmosphere is the layer of gases surrounding the Earth. It's very, very thin compared with the actual size of the Earth, but we still consider it to be made up of four main layers that you can see on the diagram here, from the troposphere, stratosphere, mesosphere, and thermosphere, extending in altitude. Each one with its own composition and its own particular properties in terms of temperature and pressure, but the troposphere being made up of the four main gases: nitrogen, oxygen, argon, and carbon dioxide. Carbon dioxide is going to feature again in what we talk about at the end of this video. But so then being able to understand how the atmosphere is put together. And then to put into context, just for your interest, that's where the ozone layer would sit, in that kind of lower section of the stratosphere. So what is the electromagnetic spectrum? We're thinking about this in the context of what is the sun doing? But remember, in terms of the bigger picture, that it's the spectrum or the array or the broad kind of picture of electromagnetic or EM waves or radiation that exist in the universe. We can see that these waves have different properties called wavelength, energy, and frequency, and then across this spectrum that they vary in these properties. So we've got a really high energy, short wavelength, high frequency gamma rays up one end, all the way down to really long wavelength, low energy radio waves down the other. This little band of visible light in the middle here, and just on either side of that we've got the ultraviolet, which is just higher than our violet colour, and infrared, which is just lower than our red colour. So this kind of area in the middle here is particularly what we're going to focus on in the context of what the sun is doing. That is because the sun, as we know, gives off electromagnetic radiation. It's the reason that we can see during the daytime. We feel warmth when the sun is out, compared with when the sun is not, daytime and nighttime. Okay, the sun gives off various types of electromagnetic radiation, typically in that middle section of the electromagnetic spectrum, but not all of the types of radiation are given off equally. The electromagnetic radiation that the sun gives off, or that hits the Earth from the sun, is called insolation, kind of coming from that same root word as solar. And so we see this range of wavelengths from the UV to the visible kind of light that we can see, and then all the way to various patterns in the infrared. But you can see from this graph here that the amount, the intensity of that light varies, as in we don't see all of these wavelengths or all of these types of light to the same degree. The sun primarily gives off in the visible kind of area. That's why it gives us light during the daytime. But also we get these other wavelengths on either side. We see that the atmosphere, what we would see if we were outside the atmosphere versus what we see at sea level, are different because of the effects of the atmosphere, and that's partly what we're going to look at now. But first of all, we want to discuss what we mean by this word greenhouse. Okay, depending on exactly how much gardening experience you may or may not have, you may not already understand or have seen what this looks like, or it may be completely unfamiliar. But a greenhouse is a contraption or a construction that you would use to help grow plants in the garden. It's designed to trap energy from the sun, especially useful in cold climates if we're trying to grow plants in a climate that wouldn't normally support it. The idea is that the sun's short, like high energy kind of waves pass through the glass, but when they hit the ground, they heat up the ground, which gives off infrared radiation. That infrared radiation, however, is trapped by the glass. It doesn't pass through the glass. Some very long wavelength rays that are just a bit beyond that can pass through back into the atmosphere, but lots of the other ones will actually get trapped in here. They will heat up the air inside, that will rise up, the glass will absorb it, and then circulate this warm air inside the greenhouse. And so the idea is that this thin layer of glass or plastic, whatever it is that's covering the greenhouse, has a really key role to play in making this process work. That it is designed to allow that energy in, but not out again. And so that's kind of the key thing I want you to take away from that part. because we see that that layer of gases surrounding the Earth, this thing that we call the air, has the same function as the glass. So if we look at it in kind of stages, so we think about our insolation, that sun's radiation that travels towards the Earth, some of which, about half, is reflected or absorbed by clouds, or doesn't make it all the way to the ground. The rest makes it all the way through the atmosphere to the ground. It's absorbed by the oceans and by the land, so it's not just a land effect or an ocean effect. Some of which then will get rebounded back, so it will be released back towards space. Some of it passes directly through the atmosphere, so it just keeps going back out again. But a significant amount of this energy that is given off by the land, which is absorbed by the Earth and then is emitted, is captured by the atmosphere. So this is infrared radiation that the Earth is giving off. Okay, so we've got a range of different types of higher energy radiation that's coming from the sun. The Earth is absorbing and emitting infrared, which is being trapped by that layer. Okay, so specifically we're talking about these things called greenhouse gases. That is, particular substances in the atmosphere that will absorb this infrared radiation and stop it from being lost back out into space. So it's captured, it's retained. That is, it warms up this air that circulates around that then maintains the Earth's temperature to be warmer. It means that then the overall average temperature is warmer, but also it is much more consistent. We see planets that don't have an atmosphere, that they go from extremely high temperatures where the sun is on them to extremely low temperatures on the side where it's not, because there's none of this kind of this maintenance of that temperature. It acts a bit like a blanket in wintertime, that idea that it kind of trapping that energy that would otherwise be lost, keeping things warm. And so it's particularly down to certain gases in the atmosphere that will absorb this infrared radiation. We call these greenhouse gases. Okay, so here are four of the key ones that are involved. So water vapor is very much an important greenhouse gas. But then some of the ones that you might be more familiar with, so carbon dioxide being the major one, methane as well, and then nitrous oxide, which is N2O, to a lesser extent. The idea is that these molecules, they will absorb the infrared that is emitted by the Earth's surface. They have, it hits them in the right sort of way that they vibrate. And so instead of allowing that energy to get lost, that they absorb it, they vibrate, they release that energy to the particles around them, keeping the whole kind of atmosphere warmer. That is, that infrared is prevented from escaping into space. It is trapped and absorbed by these molecules and re-radiated, or kind of given out, back into the atmosphere, back down to the Earth to keep it warmer. Now, the amount of energy that these gases absorb is dependent on how concentrated they are. That is, how many of these particles are in the atmosphere at any given time. As the concentration increases, the amount of energy they can trap and absorb increases. That, therefore, causing an increase in temperature. That is what we would refer to as global warming. Okay, we're going to unpack that a little bit further in the future. Alright, so we looked at the atmosphere, the layer of gases surrounding the Earth, that we see that it's got layers, and then we've got different kind of concentrations of gases within it. We looked at the electromagnetic spectrum, this array of different types of electromagnetic or EM radiation, of which the visible light is kind of in the middle part. We looked at solar radiation or insolation, the energy that comes from the sun and it's absorbed by the Earth. We looked at the concept of what a greenhouse is and why we use that as an analogy, and then looking at it in the context of what the atmosphere is doing and seeing how the greenhouse gases in the atmosphere are responsible for making that work. Alright, thanks very much for watching. Don't forget to like and subscribe. Bye for now.